is r equal to summation r equal to 0 to 9 x to the power r is divisible by summation s equal to 0 to 9 x to the power s. Now let's start the solution. Now we have already known the condition of divisibility of a function by a function. Suppose fx, that is fx is polynomial function, fx is polynomial function fx and phi x, fx and phi x, fx and phi x are fx and phi x are polynomial function, are two polynomial function, are two polynomial function in X. Then if fx is divisible by phi x, then all zeros, all the zeros, that is roots, zeros of phi x belong to the set of zeros of fx. This is the condition of divisibility. That is, two polynomial function fx and phi x. Fx is divisible if divisible by phi x if all zeros of phi x belong to the set of the zeros of fx. Then we can say fx is divisible by phi x. Now we have to prove this is divisible by this, so we follow the condition of this divisibility. Condition of divisibility, we follow the condition of divisibility. Now let write down two polynomial function, that is let fx equal to summation r equal to 0 to 9 x to the power r and phi x equal to s equal to 0 to 9 x to the power s, two polynomial. Now phi x equal to this is x1 plus x square plus x cube plus dot x to the power 9. This is the polynomial for phi x. Phi x is the polynomial, is this. The polynomial of phi x is this. Now if we multiply both sides by 1 minus x, so 1 minus x into phi x equal to 1 minus x this, and we find out the roots of this polynomial, that is 1 minus x equal to 1 minus x to the power 10. We have to find out the roots of this polynomial 1 minus x to the power 10. That is, we equate it with 0. 1 minus x to the power 10 is taken as 0 to find out the roots of the polynomial equation, that is 1 minus x to the power 10. So So 1 minus x to the power 10 equal to 0, that is, this implies x to the power 10 equal to 1. 1 can be written as cos 2n pi plus I sin 2n pi. So x equal to cos to the power 1 by 10. So we apply the de Moivre's theorem here. Now we get cos this is, and also n equal to 9. Here if we put n equal to 0, if n equal to 0, then x equal to cos 0 plus I sin 0, that is 1. So the zeros of phi x equal to zeros of phi x are cos 2n pi by 10 plus I sin 2n pi by 10, where n equal to 1, 2, 3 dot n. Here n equal to 0 is excluded because for n equal to 0, x equal to 1, and x equal to 1 is not the root of phi x. So if we exclude the 0, 1, the other roots are the roots of phi x. Other roots of x to the power 10 minus 1 equal to 0 are the roots of phi x. So the zeros of phi x are cos 2n pi plus I sin 2n pi by 10, cos 2n pi by 10, I sin 2n by 10, n equal to 1 to 3n. These are the zeros of phi x. Now we should verify these zeros belong to the set of the zeros of this polynomial function. We have to verify this. To verify this, we write down the polynomial function fx equal to equal to 1 plus this. This is the polynomial function. We have to prove the function fx is divisible by phi x. That is, the zeros of phi x are cos 2n pi by 10 plus I sin 2n pi by 10, n equal to 1, 2, 3 to n dot n. These are the zeros of this. These are also zeros of this function. These are also zeros of this function. That is, the zeros of phi x belong to the set of zeros of this function. Now we have fx equal to, now zeros of phi x are x equal to, zeros of phi x are 2n pi These are the zeros of phi x. We have to prove that these zeros belong to the set of zeros of this polynomial. We have to prove it. If we prove it, then we can say this is divisible by this. Now, fx equal to, we can write fx equal to 1 plus x to the power 10 to the power this, x to the power 10 to the power this, x to the power 10 this. Now we have already got, now we have got x to the power 10 equal to 1. X to the power 10 equal to 1. That is x to the power 10 equal to 1, or we can say for x equal to cos 2n pi by 10 plus I sin 2n pi by 10 for n equal to 1 to 3.9 x to the power 10 equal to 1. For n equal to 1 to 3.10, this x equal to this, then x to the power 10 equal to 1. So fx equal to 1 plus 1 to the power dot dot this. So fx is this. So fx is also 1 plus x square plus x cube plus x to the power 9. That is phi x. That is phi x. So the roots of phi x are the roots of fx. So roots of phi x are the root of fx. Fx equal to phi x for x equal to cos 2n pi by 10 n equal to 1 to 3 dot dot 9. 1 to 3 dot dot 9. So we can conclude that the zeros of phi x equal to s equal to 0 to 9 x to the power s belong to the set of zeros of fx equal to r equal to 0 to 9 x to the power r. So we can say as the zeros of phi x equal to s equal summation s equal to 0 to n s to the power s belong to the set of zeros of fx equal to r equal to 0 to 9 s to the power r. So we can say that this is divisible by this. So we can say r equal to 0 to 9 x to the power r is divisible by thus we have proved this. Thus we have proved that r equal to 0 to 9 s to the power r is divisible by s equal to 0 to 9 x to the power s. So I request you to like this video and subscribe my channel.